The current state of the AI industry can be compared to a game of musical chairs, where key players are switching seats, forming new alliances, and disrupting the status quo. Much like in high school, individuals gravitate towards those who share their interests, but as time passes, allegiances may shift. In the case of OpenAI, the company has recently experienced significant changes at the top. With the departure of co-founders Sam Altman, Greg Brockman, and John Schulman, rumors of internal conflicts and differing interests have surfaced. While the exact reasons for their departures remain speculative, it's clear that OpenAI is undergoing a period of transition, reminiscent of the ever-shifting social dynamics in high school. Similarly, Stability AI has also been met with its fair share of drama. Co-founder Cyrus Hodes filed a civil lawsuit against fellow co-founder Imad Mostaq, alleging that he was misled into selling his 15% stake in the company for a mere $100. This dispute parallels the kind of contentious interpersonal conflicts that often play out in high school hallways. In the world of AI, these shakeups serve as a reminder that the industry is far from static. As key players continue to move between companies and pursue new ventures, the landscape will inevitably change, mirroring the fluid social circles of high school. With each new partnership and venture, the AI industry's future becomes increasingly unpredictable, leaving us eager to see where the chips will fall. In the ever-evolving world of AI, it's common for talented researchers to move between companies. Sometimes, when these experts leave, they decide to create something new and exciting with their friends. This is exactly what happened with the researchers behind a cutting-edge technology called latent diffusion, which has significantly improved the quality of AI-generated images. As these researchers departed from their previous company, they joined forces with a lesser-known AI firm called Black Forest Labs. Together, they worked on a secret project that would take the AI world by surprise. Recently, Black Forest Labs announced a new set of models called the Flux .1 suite. This announcement caught everyone off guard because the company seemed to come out of nowhere with a state-of-the-art text-to-image generator. People were both impressed and suspicious. Could this be too good to be true? But the reality is that this breakthrough was born from the power of friendship and collaboration. By combining their skills and expertise, the researchers at Black Forest Labs have created something truly remarkable. Their Flux .1 suite sets a new standard for AI-generated images, with improved detail, better adherence to text prompts, and increased creative possibilities. So, while it may have seemed like Black Forest Labs appeared out of thin air, their success is a result of dedicated researchers joining forces to push the boundaries of AI technology. This story reminds us that even in the competitive world of AI, friendship and collaboration can lead to incredible innovations. The formation of Black Forest Labs, a superstar lineup in AI research. Imagine if a group of the world's best basketball players decided to join forces and create their own team. This is similar to what happened when some of the most talented AI researchers from the field of image generation came together to form a new research lab called Black Forest Labs, BFL. BFL's team includes almost all the authors of the original latent diffusion paper, which greatly improved AI-generated images. But that's not all. They've also brought on board almost all the authors of Stable Diffusion 3, a game-changing development that combined transformers and image generation techniques to raise the bar even higher. In total, BFL has 15 researchers on their team. When you look closely, you'll notice that 14 out of the 17 original authors of Stable Diffusion 3 are now part of Black Forest Labs. They've even added an expert named Niles, who is responsible for their powerful computer infrastructure. Essentially, this team is like an AI version of the Avengers, a group of exceptional individuals coming together to achieve incredible things. One question remains: how did they secure the funds to support their ambitious goal? Well, with such an impressive lineup, investors were quick to back them. Black Forest Labs received $31 million in Series C funding, led by renowned venture capital firm Andreessen Horowitz, A60Z, along with other notable investors like Gary Tan from Y Combinator. With financial backing and a stellar team, Black Forest Labs is poised to make groundbreaking advancements in AI-generated images. They're focused on developing the best models possible without any external distractions. The future of AI image generation looks brighter than ever, thanks to this remarkable collaboration of the finest minds in the field. Black Forest Labs' Flux models, versatility and performance in AI-generated images. Black Forest Labs recently unveiled their Flux models, an impressive suite of AI-generated image tools. The Flux models come in 3 distinct variants, each catering to different user needs. Flux Pro, designed for professional use, this high-performance model offers unparalleled image quality, detail, and output diversity. It can also generate text within images, providing an additional layer of complexity and flexibility. Although the Flux Pro model is currently only available through APIs for commercial use, it's clear that Black Forest Labs aims to maintain a reliable source of income while offering top-notch AI capabilities. Flux Dev, tailored for developers, this open-source model offers remarkable quality and prompt-following capabilities. With the ability to run locally, the Flux Dev model is a distilled version of the Flux Pro, ensuring strong performance while being accessible to a broader audience. Flux Sched. This model is optimized for scheduling and can generate images with precision and efficiency, making it ideal for users looking to streamline their workflow. The Flux models showcase their versatility and performance through various examples. They can generate high-quality images of everyday scenes, like a girl laying on the grass, and maintain consistency throughout. Furthermore, they can handle complex prompts, including generating photo verifications. However, this feature might raise some concerns and warrants careful consideration. In summary, Black Forest Labs' Flux models are revolutionizing AI-generated images, offering a range of options for users with different needs. With their impressive capabilities and performance, these models represent a significant step forward in the world of AI-generated imagery. Distilled models and their trade-offs. In AI-generated imagery, distilled models like Flux Dev and Flux Sched have their own unique strengths. These models are created by fine-tuning a smaller model to emulate the capabilities of a larger one. This process can make them less flexible and harder to customize due to their inherent instability during fine-tuning. As a result, creating character-specific models with limited data can be more challenging. Flux Dev, which is optimized for developers, comes with some usage restrictions. It's intended for non-commercial use, meaning you can't make money using this model. If you're seeking a commercial solution, you'll need to contact the company directly. On the bright side, Flux Sched, designed for efficient scheduling, falls under the Apache 2.0 license. This license allows for extensive usage, including commercial applications, as long as the derivative work doesn't alter the original license terms. While both Flux Dev and Flux Sched are distilled from the Pro model, Flux Sched has an additional step distillation process. This method enables faster image generation, requiring fewer steps and less computational power. However, there's a trade-off. The resulting images may be of lower quality compared to those produced by the Pro model. Additionally, the weights of the autoencoder used in Flux Sched are also available under the Apache 2.0 license. In summary, the Flux Dev and Flux Sched models have unique applications and limitations due to their distillation process. While they offer benefits like flexibility and fast image generation, they may come with trade-offs such as reduced image quality. Users should consider these factors when selecting an AI-generated image model to suit their specific needs. Local use, control options, and fine-tuning Flux, the new AI-generated image tool, can be used locally on your computer through interfaces like ConfyUI or SwarmUI. While Flux does not include classic generation hyperparameters like CFG and negative prompts, its enhanced prompt following abilities make up for it. Still, if you prefer using those functions, some users have shared workarounds to incorporate them into Flux. Control options, like ControlNet and iPrompt Adapter, are currently being developed for Flux. The CNY Edge ControlNet model is now available on ConfyUI, which has recently added support for Flux.1 Dev. Alternatively, you can use image-to-image methods for compositional control. Check out Nerdy Rodent's video to learn more about this technique. For image painting, you can utilize a hugging face space designed for Flux.1 Sched. Although style transfer is not currently supported, and artist names and some female celebrities have been removed from the dataset, you can still experiment with personalization. XLab AI has developed a codebase that enables full model and LoRa fine-tuning, allowing you to customize your results. In summary, Flux offers various ways to experiment with AI-generated imagery, both locally and through different interfaces. Even with some limitations in control options and dataset content, users can still explore Flux's potential by trying different techniques and utilizing resources like Nerdy Rodent's videos or XLab AI's codebase for customization, enhancing Flux output quality with customization options and efficient hardware. Black Forest Labs' dedication to improving Flux AI image generation extends beyond the basic models. Users have developed a LoRa called Cold Flux Realism, which significantly improves the realism of generated images, making them look less AI-generated and more photorealistic. For those interested in customizing their Flux models, repositories like Simple Tuner allow users to fine-tune full and LoRa models to better suit their needs. While some speculate that LoRa training for Flux is challenging, experiments like one using a single 4090 GPU with 8-bit mixed precision and 3 seconds per iteration prove that it can be done. Even without using LoRa, Flux models achieve impressive results on their own, demonstrated in Black Forest Labs' ELO rankings. For example, Pearl ranks first, Dev second, and Sked fifth, even outperforming Midjourney v6. The best part? Flux can be run on as little as 12 GB VRAM or even 4 GB VRAM with longer generation times for users with less powerful hardware. This flexibility ensures that Flux's impressive AI-generated image capabilities are accessible to a wide range of users, regardless of their hardware limitations. So, whether you're experimenting with LoRa for Flux, using Black Forest Labs' pre-existing models, or just trying to make the most of your available resources, there's no doubt that Flux is pushing the boundaries of AI-generated imagery and making it more accessible than ever. Understanding architecture, exploring fundamentals with Brilliant.org, and staying updated on AI research. The recent success of Flux Point 1 can be attributed to its advanced architecture, which incorporates diffusion transformers and shares similarities with other open-source models like AAOW and Stable Diffusion 3. This allows Flux to handle aspect ratios and resolutions more flexibly, surpassing the limitations of traditional image padding or stretching during training. With the impressive performance of Flux, Black Forest Labs is now exploring text-to-video models, as hinted on their website. Initial demos show promising results, indicating that the company is committed to pushing the boundaries of AI-generated media.